Good day, everyone. Welcome to Math Class with Sir Casey. I'm Casey Matiken Igo, and today I will gonna teach you about principle of mathematical induction. So, guys, are you now ready? Let's get
Do you
started.
know, guys, the principle of mathematical induction is often compared to climbing an infinite staircase? First, you need to be able to climb up to the first step. Second, if you are on any step, or n equals to k, you must be able to climb up to the next step, or simply as n is equals k plus 1. If you can do these two things, then you will be able to climb up.
Now let's start to our discussion. The principle of mathematical induction. Let P of n be a property or statement about an integer n. Suppose that the following conditions can be proven. So there are two conditions. So first condition, P of n sub O is true. That is, the statement is true when n equals n sub O. So second condition, if P of k for some integer k is greater than or equal to n sub O, then it is also true for n equals k plus 1. Let's take a look some examples of proving summation identities with the use of principle of mathematical induction. So example, using mathematical induction, prove that 1 plus 2 plus 3 plus plus m equals to n quantity n plus 1 over 2. So, condition 1. We need to use the condition 1 because it is the first step for getting the proof. So, the left hand of the equation consists of one term equal to 1. The right hand side becomes, so we need to let n equals to 1. So 1, quantity 1 plus 1 over 2 equals 2 over 2 equals to 1. So hence the formula is true for n equals to 1. So as you can see to the equation that all the n is substituted by 1. We are done from condition 1. Now let's proceed to condition 2. Assume that the formula is true for n equals k is greater than or equal to 1. 1 plus 2 plus 3 plus plus k equals k quantity k plus 1 over 2. We want to show that the formula is true for n equals k plus 1. That is 1 plus 2 plus 3 plus plus k plus quantity k plus 1 equals quantity k plus 1 quantity k plus 1 plus 1 over 2. So the n in here is substituted by k plus 1. So we need to get this formula to prove the equation. So the important matter in here is this is the equation that we need to prove. Let's proceed. Using the formula for n equals k and adding k plus 1 to both sides of the equation, we get 1 plus 2 plus 3 plus plus k plus quantity k plus 1 equals k quantity k plus 1 over 2 plus quantity k plus 1. So, the both sides of the equation is added by k plus 1. And now, we need to get the LCD to add both sides of the equation. And now that we got the LCD, and that is k quantity k plus 1 plus 2 quantity k plus 1 over 2. And now we need to arrange our equation. So the equation that it is arranged is quantity k plus 1 quantity k plus 2 over 2. And lastly, we need to factor to get the proof or to show the equation. And that is k plus 1 bracket quantity k plus 1 plus 1 close bracket over 2. So we have proven the two conditions required by the principle of mathematical induction. Therefore, the formula is true for all positive integers n. But, reminders. So after getting your proof, so don't forget to write the end of proof sign, or what we call lapida. Before I will end my video, there are two conditions on proving summation identities with the use of principle of mathematical induction. The first condition is P of n sub O is true. That is, the statement is true when n equals n sub O. So, second condition, if P of k is true for some integer k is greater than or equal to n sub O, then P of k plus 1 is true. That is, if the statement is true for n equals to k, then it is also true for n equals to k plus 1. So that's all. Thank you for listening, and God bless.